Hi guys, welcome back to A Case of Econ Struggles. Today we're talking about Pareto Optimality and the fact that Pareto optimal allocations are not always equal to competitive equilibrium allocations, although they can be. Timestamps are below if you'd like to jump around, but let's get right into it. First, let's start with an intuitive definition of Pareto Optimality. We've sort of talked about this before, but we're doing this now in more depth. So Pareto Optimality is that you can't make one person better off without making at least one other person worse off. So for example, if someone's already doing as well as they can, so as an example, maybe you've got two people and one person comes in with all of the cookies and both people like cookies. Well, you can't make the other person who currently has no cookies better off without taking cookies from the first person. And if you take cookies from the first person, you're going to make them worse off because they like cookies and want all the cookies. To make that intuitive definition a little more rigorous, a little more mathematical, we're going to use some notation. So an allocation between two people, C1, C2 with these little party hats is Pareto optimal. If there does not exist some other allocation C1, C2 with little tildes over them, such that the utility of the first person of the new allocation C1 tilde is greater than or equal to their utility with the old allocation, and the second person is doing just as well as they were before. So that's just what we said before. All this is saying is, again, you can't make one person better off. You can't increase their utility without making the other person worse off. And of course, we have this feasibility constraint because if we have 10 cookies we're dividing between two people, it might be better to give each person 20 cookies instead of 5 cookies, but you can't give everyone 20 cookies because you only have 10 cookies, you don't have 40 cookies. So we just have to add in this feasibility constraint here. Let's do another example, but this time let's write it down and go through it a little more carefully. So this is an example with Bill and Dave, our favorite two people. Bill really likes Pepsi and he hates Coke. Dave loves Coke and hates Pepsi, and they walk into the same room. They put all their soda on the table. Bill has 10 Coke and 2 Pepsi, and Dave has 10 Pepsi and 2 Coke. So it might be pretty clear that it's Pareto optimal for Bill to get all the Pepsi and Dave to get all the Coke, and that's exactly what we have here in green, where we say it's Pareto optimal for Bill to get the 12 Pepsi and Dave to get the 12 Coke. Just like we said before, it's not Pareto optimal for Bill to get 20 Pepsi and Dave to get 20 Coke because we don't have 20 Pepsi and we don't have 20 Coke to give out. That's not feasible, so it's not Pareto optimal. Another thing I want to talk about is throughout our entire conversation so far about Pareto optimality, we haven't talked about prices at all, and that is on purpose. When we're talking about Pareto optimality, we are not focused on prices. Pareto optimal allocations are allocations. They're not outcomes. They don't come out of a market. You can think of it as we have a social planner who is deciding how much Coke and how much Pepsi to give from Dave and Bill. So it's almost as if Dave and Bill give all their Pepsi and all their Coke to a social planner, and then the social planner redistributes that Pepsi and Coke to be Pareto optimal. So a Pareto optimal outcome comes out of what we call the social planner problem, and we'll talk about that in more detail in the next video. But the main thing here is, again, we're not focused on prices. Prices have no bearing in a Pareto optimal setting. With that being said, I mentioned earlier that Pareto optimal is not always equal to competitive equilibrium, so let's do a quick example of that. So here's a monopoly setting. So we've seen this before, and we'll see this again in future videos, where the Pareto optimal allocation is here in green. That's where the supply curve equals the demand curve, and we have this quantity in green here. With a monopoly, they have a marginal revenue curve. That's this pink line, and they are going to set the quantity equal to where the marginal revenue equals the supply curve. So notice that this competitive equilibrium quantity is much less than the Pareto optimal allocation. I also said that Pareto optimal allocations could be equal to a competitive equilibrium outcome, and if we ignore the marginal revenue line, so we just have supply and demand, this would represent the equilibrium in perfect competition, which is exactly equal to the Pareto optimal outcome. So in that case, the Pareto optimal and the competitive equilibrium would be the same. I'm just trying to illustrate that that is not always true. Finally, to bring this all together, let's talk about what I call the allocation onion. Some people call it slightly different things, but we're all talking about the same picture. So these are all the possible allocations of goods that we can have. We have feasible allocations in pink, right? Some allocations are not feasible, but most are feasible. Then we have efficient, which means that we are allocating all the resources we have to allocate. Then within those efficient allocations are Pareto optimal allocations, and then a subset of Pareto optimal allocations are competitive equilibrium. So this is the picture I have in mind when I'm just thinking about the different types of outcomes. But hopefully this was helpful in talking about Pareto optimality, what it means, and how it differs from competitive equilibrium with some examples. If this was helpful, make sure to like and subscribe, and we will see you next time for another case of Econ Struggles.